some time in the life of a chemical engineer. I'd worked down in Houston, Texas on two chemical plants for 3 years that utilized a EMC Controls MCON D2 control system architecture, which is large industry standard system, right? Developed out of basically our space program, electronics and controls. So this outfit EMC modules, very big, very discrete back-end manufacturer for a lot of custom high-end electronics. Comparable to like a Thiess in Germany or someone like that, or Thiess in France. So these houses are out here that do this, but this one is an exception or exceptional because of its applications into large industrial controls. Another video I talked about how this control system that we commissioned and ran replaced hundreds of people a shift running a chemical plant. It relieves safety margins, high tech in the time, in the 80s. So this was a three-layer distributed control system. Well, about 5 layers, but basically from a controls architecture. And this was a base design. The next, the MCON D2, D3 control system was a VAX clustered architecture versus DEC systems architecture. So now you have huge computer processing power and a high-speed backbone that we didn't have with the D2 control system. Most of my interfaces were RS-232, so work like speeding up those RS-232 lines when new hardware became available, and up in communications paths because we had to bitwise monitor RS-232 lines in order to be able to add any communications flows. That's how densely packed the communications timing was. If you throw in DECnet or DUNANET protocols, you have some timing issues. When you throw in internet protocols, you have some packet delivery issues. So next job after that chemical plant was going to work for a contractor to the Department of Defense on nuclear materials processing. The job as a senior chemical engineer was designed at low-level interlocks in this D2, D3 control system, and those interlocks basically, if they hit, basically it was a truth table. 2 out of 3 had to be true, or you shut the plant down and you bury it in concrete. That's the level of the interlock for this particular system. So the first thing was going to about 3 months of schooling on the new D3 control system architecture and VAX clusters and signal processing and signal passing between the processors. When you're dealing with these low-level interlocks, Digital Equipment expanded their bus specifically for this instrument and or for this type of instrumentation and controls processing. And so that was still kind of under testing, even though it was a released hardware for Digital Equipment Company to be used in this specific an application because of timing considerations had not been fully evaluated. So after learning of the D3 architecture, basically, which consisted of VAX clusters instead of a single DEC computer controller at the top end for supervisory controls, the architecture changed, the control timing path changed. So if you're familiar with direct memory access and memory mapping and memory reads and writes, at this level, I have to worry about the signal timing for these low-level interlocks to come in. While my device is connected directly, indirectly, to the equipment out in the field that will make these decisions, right? At least 2 out of 3 compressors have to run. I have to worry about the memory resident state of those inputs, and that my CPU has processed all of those inputs in the same state. If the inputs bounce, I have to debounce them somewhere, and that has to be accounted for because of timing issues. I'm working in millisecond decisions. And like I said, if the plant shuts down, So I had a good 3, 4 months of training on newer updated systems. The thing that was new, I knew about TCP/IP protocols and message insecurities. So you have to defense in depth, right? Risk analysis. You have to weigh all these communications paths. And because of the segmentation of the project, I had to write letters to other people to be able to get answers back on this communications path. So the other choice was to go through design documents, which I was beginning my own reviews of at the time. So then the whole process was shut down. So there's an inkling into distributive control systems, EMC specific, but I've worked with every other competitor since then in this market, and it's changed because of electronics and because of clustered and distributed computing and message security and communications protocols. So while I'm worried about a thermocouple scanner device that's all by itself scanning 1,000 thermocouples out on a reactor somewhere, I'm also concerned about the RS-232 string it might be on, or the DECnet, or Ethernet protocols, or gigabit Ethernet. When these upgrades happen, you begin to change things that react in a memory resident. Remember, you're reading these bits every machine cycle. These are basically OSI layers, things that, unless you know about and how to call in your day-to-day new programming world of interpreted languages, you wouldn't know how to get to. So chemical engineering, simple stuff, right? But again, I was a distributed control system integration specialist more than a chemical engineer. But that's got to touch it. Got a pay stub.